I don't want to waste any of your time. Let's get straight to it. Why do we even have binomial theorem? This is a question students often ask me. Okay, let's start with a simple example. Let's say we have x plus 1 to the power of 3. This is x plus 1 times x plus 1 times x plus 1, right? Just by definition. We can then multiply x plus 1 times x plus 1 in one brackets, and then multiply that again times x plus 1. And we'll get x plus 1 to the power of 3 completely expanded. So we'll get the term in x to the power of 3, the term in x to the power of 2, and so on and so on. That's an important thing to note, okay? When we talk about the term in x to the power of 3, the term in x to the power of 5, whatever, it just means the number plus the x to the power to that number. So what happens though when we have x plus 1 to the power of 9? We could multiply all of them one by one, but that would take ages. So instead, that's why we have the binomial theorem. So we can use the following formula, which is in the data booklet. Very importantly, and I really want you to remember this, the x to the power of n minus r and the second term being to the power of r can be flipped, as you can see here. So you can use whichever one you prefer. So always use the one that suits the question best. So now, as an example, we can use the formula to find the term in x to the power of 3 in the previous expression. We obviously already expanded the whole thing, but this is just to show you the logic here, right? How this works. Why do we even do this? So it would be 3, that's n, on r. That's what we call it, on r. Then x to the power of 3 minus r and 1 to the power of r. Again, it could have been flipped. It could have been x to the power of r and 1 to the power of 3 minus r. I just chose that. R has to be 0 so that x is to the power of 3. So then we get 3 on 0, x to the power of 3, and 1 to the power of 0, which is just 1. How do we do the 3 on 0, though? 3 on 0, we always solve this the same way. N on r is n factorial over r factorial times n minus r factorial. A factorial basically means if we have n factorial, it's n times n minus 1 times n minus 2, etc., etc. So 3 factorial would be 3 times 2 times 1. And then 0 factorial is just 1. So in this case, we're going to have 3 factorial over 3 factorial. So 3 times 2 times 1 over 3 times 2 times 1, which is just 1, right? So in this case, the term in x to the power of 3 is 1. So it's x to the power of 3, which is what we found before. Easy. Now, let's do questions. Hopefully the concept is understood. If you have any questions, go in the comments and ask me, and I will reply. So the first one is just expand 2x plus 1 to the power of 4 in descending powers. So here, again, we could just multiply 2x plus 1 times 2x plus 1 times 2x plus 1 times 2x plus 1. But because that's a lot of work, instead we're going to use the formula for the binomial theorem to find every single term in the final expansion. So we start off with r equals 0. We fill out the formula. Again, remember the 2x to the power of 4 minus 0 and 1 to the power of 0 could have been flipped. It does not matter. And we end up with 4 factorial over 4 factorial, which is, again, 1 times 2 to the power of 4 times x to the power of 4. 2 to the power of 4 is 16, so it'll just be 16x to the power of 4. Then we find the next term, which is 4 on 1. 2x to the power of 4 minus 1 times 1. In this case, it'll be 4 factorial over 3 factorial times 1 factorial. 1 factorial is obviously just 1. Then 2 to the power of 3 times x to the power of 3. So 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So we can cross out the 3, 2, 1, and we'll get 4 times 2 to the power of 3 times x to the power of 3, which is 32x to the power of 3. Next, we have 4 on 2. Same gist. This time, it's going to be 4 factorial over 2 factorial times 2 factorial. So basically, it's going to be 4 times 3 times 2 times 1 over 2 times 2. So what we can do here is, since 2 times 2 is 4, we can just delete some things from the numerator as well, right? So we can delete the 4 with the 2 times 2 from the denominator. And once we get that, we get 6 times 2 to the power of 3x squared, which is just 6 times 8, which is 48x squared. We now do the same thing, 4 on 1, 2x to the power of 4 minus 3 times 1 to the power of 3. So that is 4 factorial over 3 factorial times 1 factorial. That, remember, we did that beforehand, so we already know what that is. That's 4, right? So it's going to be 4 times 2 to the power of 1x. So 4 times 2 is 8, so just 8x. And finally, 4 on 4. 2x to the power of 0 in this case, right? 4 minus 4 times 1 to the power of 4. In this case, 4 on 4 is 4 factorial over 4 factorial, which is 1. And then 2 to the power of 0 is just 1 as well. X to the power of 0 is just 1 as well. And 1 to the power of 4 is just 1 as well. So it's all just 1. So the expansion is 16x to the power of 4. Again, we're doing this in descending powers of x, right? Plus 32x to the power of 3, plus 48x to the power of 2, plus 8x plus 1. This is the easiest binomial question you can get. Let's ramp it up a little bit. The next one is when you actually have to find a specific term instead of giving the whole expansion. So we have x minus 3 to the power of 8, and we have to find the term in x to the power of 6. How do we do this? As always, we always go to the formula, okay? So it's 8 on r, and then x to the power of 8 minus r times minus 3 to the power of r. Since we know we want x to the power of 6, r has to be 2, right? So that 8 minus 2 is 6. Again, we could have flipped it, so we could have had x to the power of r, and then r could have been 6. It would not have mattered, okay? But we expand, so we get 8 on 2, which is 8 factorial over 6 factorial times 2 factorial times x to the power of 6 times 9. Now, here's a very, very important skill to learn. When you have 8 factorial over 6 factorial, the numbers get more complicated. So you can expand the whole thing, and what you'll realize is that actually you can cross out most of it, right? So from the 6 onwards, you can cross out. That makes it a lot easier. So what I'm writing here is super important. You can simply just write 8 times 7 times 6 factorial above, and then just cross out with the 6 factorial. This is a skill that will come in handy a lot in the harder questions. Once you have that, it's 8 times 7 over 2 times x to the power of 6 times 9. Simplifying this, it's 4 times 7, right? The 8 we divide by the 2. And doing this with a calculator, because I cannot do this in my mind, I wish. This is going to turn out to be 252x to the power of 6. I hope you got the gist here. Great. Next question, we're ramping up the difficulty again. This time, we actually don't have the n in the expression. So they're going to give us a term, obviously. So we have 2x plus 1 to the power of n. We need to find n, but they are telling us that the term in x to the power of 2 is 40n. So in this case, we have one term. So again, we're going to go to the formula, and we're going to try and find the term in x to the power of 2 to make it equal to 40n. So what you'll notice here is that here it's much easier if we flip the formula, because then we have 2x to the power of r, and we automatically know that r equals 2, right? That's easier than having n minus r equals 2. So then we can expand the formula, and again, we'll get n factorial over n minus r factorial times 2 to the power of 2 times x to the power of 2, because r is 2, times 1, which doesn't matter. And we know that this is equal to 40nx squared. So then we know that r is 2, so we can simplify that a bit. And here's where we're using the skill I told you about before. We know that n factorial is n times n minus 1 times n minus 2, etc., etc. So basically times n minus 2 factorial. So we can then cross those out, and that makes this so much easier. Because now we only have to do n times n minus 1 times 2. We simplified the 4 with the 2, and we know that that's equal to 40nx squared. We can then cross out the x squareds from both sides. So this is an equation now. We can now also cross out n and n from both sides, and we get that 2n minus 2 equals 40. We move the 2 to the other side, so 2n equals 42, and n equals 21. Boom, right? This is much more complicated, but it's still the same principles as before. Now, even more complicated, when we get two expressions. So now, instead of just having one binomial expression, we're going to have two. So in this case, they're asking us to find the term in x to the power of 2 in 1 minus 3x squared times 1 plus 4x to the power of 5. Okay, you'll notice the only one that's a binomial expression here is the second one. So that is going to be like what we've been looking at before. It's going to be a long expression with tons of terms all the way from a number to x to the power of 5. Whereas the other one is literally just 1 minus 3x squared. Don't confuse it with the binomial. So what we have to realize though is if we want the term in x squared, it's when we multiply both of them, right? The binomial times the other brackets. So if we isolate the constant term in the second one, meaning the one without an actual x, and the one x squared, when we multiply it times 1 times minus 3x squared, we will get terms in x to the power of 2, right? The 1 times the term in x to the power of 2 will be x to the power of 2, and the minus 3x squared times the constant term will also be an x to the power of 2. So, okay, here the idea is that we could actually do the whole expression for the binomial and then multiply times that expression. But again, that's very tedious. So we try and find the terms that when then multiplied times the 1 minus 3x squared will give us a term in x squared, okay? So first, we're finding the constant term. We know that for that, x must be to the power of 0. So we take r0, we do the simplification as we've been doing before, and we find that it is 1. Then we find r equals 2, so that x is to the power of 2. And we find that that is all of this that we're doing, right? So like 5 on 2 times 1 times 4x squared. We use the same techniques we've been using until now to simplify, and we find that it is 5 times 2 times 16x squared, which is just 160x squared. So now we have these two terms that we know are going to become x squared when we multiply them times the other brackets. So we do that, we cross multiply, and we find that we get 160x squared minus 3x squared. So then we add those, and it's 157x squared. I know this is really complicated, so if you have any questions, go right now in the comments and ask me, and I will try and explain it as much as I can, depending on what you don't understand. But in the meantime, let's move to a harder question. This time, it's when we have two x's in the same binomial expression. Okay, this actually happens a lot. This is, I would say, actually, maybe this is a bit easier than the previous one. So they're asking us to find the constant term in 2x minus 1 over x to the power of 10, right? So 2x's in the expression. So, but same thing as always. We use the formula 10 on r times 2x to the power of 10 minus r times minus 1 over x to the power of r. Now we have to consider both x's, right? So we need to make sure that if we're trying to find the constant term, aka x to the power of 0, both need to be considered. So we multiply both of the x terms, and we're going to simplify. So basically what we can do is we can take the 2 and the minus 1 out of this whole thing, not because they don't matter, but because right now, because we're trying to find x, we don't really care about the 2 or the minus 1, right? So once we do that, we're going to get, on the side, we're going to get minus 1 to the power of r, 2 to the power of 10 minus r. We can disregard that, and then x to the power of 10 minus r over x to the power of r. Remember, the loss of exponents, that's x to the power of 10 minus 2r, and that has to equal 0. Therefore, r must be 5. So now we have our r. So now it's a breeze from here. So it's 10 on 5 times 2x to the power of 10 minus 5, so 5, times minus 1 over x to the power of 5. So this is going to be, again, we do the factorial, so we can simplify and cross out the 5 factorial, then simplify the 10 times 9 times 8 times 7 times 6 over the 5 times 4 times 3 times 2. And then we're going to have 2 to the power of 5. The x's, remember, are going to cross out because it's going to be x to the power of 5 over x to the power of 5, which is what we wanted in the first place, right? The minus 1 is going to be to the power of 5, which is still minus 1. So we can do this with a calculator, obviously, and the result will be that the constant term is minus 8,064. That's it. Okay. And finally, another hard question. This time, they're telling us that the term in x to the power of 4 is equal to the term in x to the power of 6 in the following expression, right? So 3x plus p over x to the power of 8. We have to find p. This is similar to the one where we had to find n, but this time it's just a different number. So first, let's find the term in x to the power of 4. Again, we use the formula as always. I'm not going to explain it all word by word, but this time, once again, we have two x's. So we're combining a lot of skills here, right? We're isolating the x's, so x to the power of 8 minus r over x up to the power of r, and that has to be equal to x to the power of 4. So r is going to have to be 2, okay? Once we do that, we simplify in the expression. Again, lots of numbers here, big, so it's going to be a little harder, but it's the same techniques we've been using. And with that, we get the term in x to the power of 4. The next thing is to find the term in x to the power of 6, though, to make it equal to this one. So for x to the power of 6, we have the same isolation as before, x to the power of 8 minus r over x to the power of r, which is x to the power of 8 minus 2r. And in this case, r is going to be 1, so that x can be to the power of 6. So we do the exact same simplification with r as 1 now. So slightly different numbers, but like same story, right? We're just simplifying here with the factorials and the 3 to the power of 7, etc. And now we know that these two are equal, right? So what we want to do is we want to make the terms equal to each other. So after some simplification, this is 4 times 7 times 3 to the power of 6 times p squared equals 8 times 3 to the power of 7 times p. And we can simplify so much here because now we have an equation, right? So we can cross out a p from either side. We can cross out 3 to the power of 6 from both sides as well. And once we've got that, it really just is a piece of cake because it's 4 times 7. P equals 8 times 3. So 28p equals 24. So P equals 24 over 28. And if you simplify that with a calculator, you can get an actual number. So I hope this was useful. Any questions? I know we went through everything quickly. Any questions, leave them in the comments. I'm more than happy to answer. See you next week, guys.